Hello, we are going to work on Activity 8, starting with Lesson 8.1, the square root functions. Our learning targets are to graph and describe transformations of y equals the square root of x, or the square root function. And then we want to interpret some key features of a graph that models a relationship between two quantities. The whole speed h in knots of a boat is written or given by the function h of x is equal to 1.34 times the square root of x, where x is the length of the boat in feet at the waterline. The whole speed is a transformation of the parent square root function, and the parent square root function would be f of x is equal to just the square root of x. So we're going to graph these on the same axis. So we're going to start with graphing the square root function, f of x equals the square root of x. And to do that, we'll make a little table of values, thinking about domain, of course, that the smallest number you can put into a root would be a 0 and still get out a real number of 0. So 0 is 0. Then I want to make sure I pick squares to plug in so my answers come out kind of nice. So square root of 1 is 1. I don't really want 2 or 3, but square root of 4 is 2, and the next perfect square is 9, and that is 3. So I really want to put in numbers that I can actually plot, like 0, 0, 1, 1, and then 4, 2, and 9, 3. Okay, and that is the parent function for the square root. Okay, now if I were to graph the h of x function, so h of x equals 1.34 times the square root of x. So now all I really have to do is a transformation, which would be, this is a multiplier. So I just really need to take all the y's and multiply them all by the square root, multiply them all by 1.34. So my x and y, of course, my x's were 0, 1, 4, and 9. When I plugged them in, I got out 0, 1, 2, and 3. But if I take those y's and I multiply them by 1.34, well, I still have 0. Then I have 1.34, I'll have 2.68, and 9 times 1.34 is 4.02. Okay, and so now I will graph those. So 0, 0, of course, is there at the origin. Over 1 up 1.34 is just a tiny bit higher than before. And then over 4 is up at 2.68, so again, a little bit higher than it was before. And then at 9, it's actually up at 4.02, so again, higher than it was. So it's just slowly increasing. It's not that big of a multiplier. So next we want to talk about the domain and range of f. So for f, our domain would be all of our x's need to be greater than or equal to 0 to keep our answers real. And then in interval notation, that would be from 0 to infinity. Our range also goes all of our y's greater than or equal to 0, or again, 0 to infinity. Given that x represents the length of the boat, should the domain h of x be more restricted than f of x? Okay, well, the domain of h of x should be a non-negative number, as the same with f of x, but it really shouldn't go off to infinity. That's the only thing we would really have to change there. So I would say we shouldn't really think about going from 0 to infinity for domain or for range, because, again, we're talking about a real situation here, the length of a boat. All right. Part D says, explain how to write the square root of x using rational exponents. Okay, so the square root of x. So remember, it's like x to the first, and a square root, you could think of there being a little 2 there. So if you remember from last year, we had taken power over root for our exponent. So the square root of x can be written as x to the 1/2 power, and you will see it written that way sometimes. Okay, so if we wanted to write h of x using rational exponents, we could write h of x equals 1.34 times x to the 1/2 power. It's just another way of writing a square root. Explain how you could use transformations of the parent function to graph 2 times the square root of x. Well, we could do what we did before, and we could multiply all the y coordinates. So we could multiply all y coordinates of square root of x by 2. Okay, which is a little different than looking at question 3 where it shows g of x is the square root of 2x. Okay, so now the square root of 2x is not the same as 2 times the square root of x. So we could actually rewrite it as the square root of 2 times the square root of x. Okay, so that's different than 2 times the square root of x. That's a different transformation then. And so if we were going to do that, we'd have to multiply all the y coordinates by root 2. Not 2, square root of 2. Okay, so it will vertically stretch the graph. All right, so let's look at how does the graph of g of x, the square root of x minus 3, differ from the graph of square root of x. So here you want to think about when you're inside a quantity that we always have a horizontal shift or a horizontal translation. So if you're going to see x minus 3 inside a square root or a parenthesis or just kind of trapped somewhere, remember that's going to be a horizontal translation, meaning it's going to be a shift left or right. And the horizontal translation always does the opposite. So this one will shift actually 3 units right because it's negative 3. So that's going to be a shift 3 units right. And so knowing these transformations, stretches and shifts, we should be able to graph these pretty quickly if we use that parent function. So I'm going to go back to that parent function again where I graph the f of x is the square root of x. Remember that one was 0, 0, square root of 1 is 1, square root of 4 is 3, and square root of 4 is 2. And square root of 9 is 3. Okay, remember that's f of x. And when you're drawing multiple graphs, you could label them. That's probably a good idea to start doing. So there's f of x. However, g of x is no stretch this time. There's no multiplier in front of it. It's just going to be a shift to the right 3 units. So I could take every ordered pair and go right 3 units. So 1, 2, 3. Take this one, go 1, 2, 3, 2, 3. And this one's a little bit off the page, but that's okay. Now we have, the pink one is our g of x. So it's just a shift to the right 3. Okay, now we can talk about domain and range for both f, and this one just wants to know of g. So of my g function, my domain now, you can see that my domain starts with all the x's greater than or equal to 3. Because it got shifted to the right 3 units, or in interval notation, 3 to infinity. And then our range, our y's, of course, the y's are still starting at 0, so greater than equal to 0 or 0 to infinity. All right, well now we're going to combine some transformations together. Multiple transformations can be applied to the same basic function to create a new function. So some of these transformations will include translations, reflections, stretching, or shrinking. Okay, so now we have described the transformation that will result in the function listed below. So for our g of x, we have 2 transformations happening there. Inside the radical, we have x plus 2, so we're going to see a translation of left 2 units. Then we're also going to have a reflection. For part B, I'm going to see a translation of 3 units right and 4 units up. Okay, so now we have that k value at the end, so we're going to go up a 4. And now we can graph. So our original parent function, I always like to put on to start with, and the original parent function, of course, is 0, 0, 1, 1, 4, 2, and 9, 3. So there's the parent. Now we're going to take that function and we're going to do some work with it. For part A, the red function, that's going to be g of x. We are going to translate that function left 2 units, and then we need to do a reflection. So if I go left 2 units for each ordered pair, left 2, and then reflecting the point that's on the axis doesn't really go anywhere. And then I'm going to take the next point and going to go left 2, and then I'm going to reflect, so now it's here. Left 2, here, left 2, and here. So now this is going to be my g of x. For h of x, we're going to have to do 2 translations. We want to go 3 units to the right and 4 units up. So I'm going to take my function and go 3 units to the right. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. So each ordered pair will do that. 1, 2, 3, 1, 2, 3, 4. And that's probably about all we can fit right now. And there will be our h of x function. Number 11 says, without graphing, determine the domain and range of the function. All right, so for domain, remember, we always want to think about what's underneath that radical. And in that radical, we have x plus 5. And so we have to think about the fact that x plus 5 must be greater than or equal to 0. So if I subtract 5 on both sides, x must be greater than or equal to negative 5. So that's going to be my domain. X is greater than equal to negative 5, or we're going to go from negative 5 to infinity. So for range, plugging in a negative 5 will give me a 0, but then 0 minus 1 is negative 1. So my range is going to be all y's greater than or equal to negative 1, or going from negative 1 to infinity. And now we get both notations there, set notation and interval notation. So I'm going to save some of the other ones to do in class, to check your understandings, and then, of course, some of the practice.